Hello everyone, welcome to the channel. In previous lecture, we discussed some fundamental concept of thermodynamics such as state of the systems and functions of the systems like state functions and path functions, and thermodynamic process like isothermal process, adiabatic process, isochoric process, and isobaric process, and cyclic process. Then when there is properties of the systems like intensive properties and extensive property with the help of some simple examples. So now we have built strong concept for thermodynamics. So today we will understand thermodynamics in more detail. So in this lecture we will learn some more very important concept of thermodynamics, including internal energy and how internal energy of any system can affected by factors like temperature and heat, and conversion of heat into the work and vice versa. And what is the difference between heat and temperature, and the law of energy conservation, and finally we see the first law of thermodynamics. So these topics are very important for your board exam as well as your competition exam. So make sure you stay focused and watch this lecture till the end. So let's get started. So let's start with internal energy. Suppose we take a gas inside the beaker and imagine in at microscopic level. We will observe that gaseous molecules have some kinetic energy due to their transition motion and rotation motion in their axis or vibration motion in their position. They also have some potential energy due to their force of attraction or repulsion between gaseous molecules. So we can say that internal energy of any system is equal to sum of all the kinetic energy and potential energy of all the molecule present in the system. So let's study internal energy in more detail. If we don't break the bond between gaseous molecule, then the kinetic energy of the gaseous molecule increases with increasing temperature. As the kinetic energy of the gas molecule increases, the internal energy of the gaseous molecule also increases. The internal energy is a state function, means it only depends on initial state and final state of the system. It does not depend on the path or process taken, as we discussed in our previous lecture about the state functions. Since it depends only on the number of molecules, so it is an extensive property. We will represent internal energy as U, and its SI unit is Joule. Measuring the absolute internal energy is very difficult. So we can only measure the change in internal energy during the change in state. So next topic is the law of conservation of energy. We can understand law of conservation energy by change in internal energy. So let's see how we can change the internal energy of any system. It can be changed in three ways. First, if system exchange their heat with its surrounding. Second, when work is done or by the system. And third, matter is entering or leaving the system. So let's see how internal energy changes through a heat exchange. If we add heat to the system, the motion of the system's molecule increases because as the temperature increases, system's kinetic energy increases. An increase in kinetic energy means that the system's internal energy increases. So now we can conclude that the average kinetic energy of any system is directly proportional to the temperature of that system. So let's see what is heat. Heat is the form of energy, especially thermal energy, that transfer between a system and its surrounding due to temperature difference is called heat. For example, when a hot cup of tea is kept on table, heat flows from the hot tea to its cooler surrounding until both reach to the same temperature. So next is, when we think about heat and temperature, the question arises in our mind is what is the difference between heat and temperature? So let's see what is the difference between heat and temperature. Heat is the transfer of thermal energy, while temperature is the measurement of degree of hotness and coldness of the system. The unit of heat is joule, while the unit of temperature is Kelvin. Heat is always transferred from a hot object to cold object, or we can say that heat is transferred from higher temperature to the lower temperature object. When calculating a heat in thermodynamics, we assign it a sign. If heat is entering to the system, the sign of heat is given as positive, whereas if the heat is leaving to the system or system is releasing the heat, the sign of heat is given as negative. So let's see how we can change the internal energy of a system due to work done. We can calculate work done of 1 kilojoule in two ways. In first way, we take insulated system. The insulation is important because system cannot exchange their heat to its surroundings, and we are doing work by adding a pedal. During this process, the temperature of system increases, which we can measure on thermometer. The temperature of the system increases means internal energy of the system is changing. And in the second method, if we pass a piston through insulated system and when we compress the gas with piston, the temperature of the gas increases. The increase in temperature will increase the internal energy of a system. From this, we can conclude that the internal energy is state function because in the both the cases the change in internal energy is exactly 1 kilojoule. So now let's see how internal energy of a system can change by exchange of matter. When matter enter to the system, the number of molecules inside the system increases. As the number of molecules increases, the internal energy of system also increases. However, when matter leaves to the system, the number of molecules will decrease inside the system. Therefore, internal energy of a system decreases. So let's start the first law of thermodynamics. The first law of thermodynamics was proposed by Hermann von Helmholtz and Julius Robert Mayer. This law states that energy can neither be created nor be destroyed, but it can only be converted from one form to the another form. So mathematically, we can express change in internal energy of a system will be equal to sum of heat exchange and work done, where heat exchange and work done are path function and change in internal energy is state function. We have just read that the internal energy of any system can be changed through heat exchange or work done. If we do not exchange heat and do not done any work on the system, there will be no change in system's internal energy. Since isolated system do not interact with its surrounding, therefore we can say that the total energy of isolated system always remains constant. Because of this idea, the first law of thermodynamics, also known as the law of energy conservation. For example, when we burn a fuel in engine, the chemical energy of fuel is converted into heat energy and mechanical work. Here, energy is not created or not destroyed, it is just changing from its form. So let's understand the first law of thermodynamics more clearly with the help of question. In this question, we are living a system and we are not doing any work on the system, but we are removing q amount of heat from the system. So we have to calculate system's internal energy in heat related terms and also tells what is the type of walls system has. So take few seconds and solve it. So now let's see what is the answer will be. Since we have do not done any work on the system, so the value of W will be 0 and the system has lost heat, so by conventionally the sign of Q will be negative. So the change in system's internal energy is generally equal to Q plus W. Because of that, the change in internal energy now become minus Q and the system can lose energy, which means the wall of the system are conducting. If you found this lecture helpful for you, then like the video and subscribe to the channel for more clear and concept based chemistry lecture. See you in next lecture. Keep learning, keep growing.